Last week, OpenAI released a new capability for its Gen AI services, structured outputs, which might not sound exciting, but I suspect it will prove to be a big deal. In this video, we're going to look at a quick example of how structured outputs made it easy for me to combine a front-end, a back-end database, and ChatGPT. It's kind of like suddenly having an API for the internet, which is freaking awesome. How does it work? Let's find out. My name is John Walls, and I've worked as a technologist for over 20 years, helping tech companies bring their products to market. I also make videos about it, especially the roles, the tools, and the techniques available to the scientists, technologists, and engineers involved. Let me know your thoughts in the comments. Before we get into the detail, let's have a quick look at what my experiment involved. Also, feel free to use the chapter markers below to skip to the technical content if you prefer. So I've got this little hobby project that I'm working on, a knowledge graph of the AI landscape. And using structured inputs, it is super easy for me to click on a node of this knowledge graph, like a vendor or a product, and on my behalf, ChatGPT effectively searches the internet and gives me a consistent summary for each node about that node. Because the format is predictable, I can easily store the result in a database. So you can see that only a few clicks are triggering a generate new summary alert as I go through the table. That means that I can then provide faster response time for future queries using whatever caching approach I want to take. And we can also work with partial information. If I add an additional field to the requested format, I can present data we already have and only wait for the incremental data to be added in. All of this means that I can optimize the user experience and the cost of the overall application, and I could easily automate most of this process rather than waiting for a user to click on a node. I can automate the bulk of the data collection and manually edit and curate the raw data. So why are structured outputs important, and why should you care? We've had LLMs widely available for a couple of years, right? Or maybe you agree that structured data is important, but you're already using something like the Instructables library or your own solution to create structured data from the outputs. Well, I think it's significant in a few ways. I could get into how solutions to date, including OpenAI's own JSON mode, are kind of bad. Instead, let's talk about why having a reliable data format and data structure within that format are important. Structured outputs are essentially about integration. Good integrations have various benefits. It makes the technical work of building, testing, and maintaining solutions easier. They open up more options for your overall architecture. It makes governance easier because your process is easier to inspect. And specifically to the AI market, right now is really good timing for streamlining integrations. It's already possible to build multi-agent systems, and structured outputs will make this easier. OpenAI added a recipe to their cookbook showing a 4-step process for data analysis, for example. You can also imagine solutions that go beyond linear sequences into ones involving branching and looping, for instance. Although there's a lot of multi-agent systems out there, I think the sheer number of the new startups online and blog posts about how to do it confirm an old truth of IT systems. The integration points between your systems and third-party systems are a significant point of friction. And while there are ways to solve for this, right now we have what could be called a lot of complexity at the surface. In the medium to long term, we want to remove this complexity so our integrations appear more seamless, while retaining all of the flexibility that makes the integration valuable. This is going to be important for successful adoption in the enterprise, where I find that the real pain tends to be not integrations within a single code base or vendor ecosystem, but between multiple different and quite separate systems. For instance, there's been a recent announcement about an integration between Microsoft Copilot and SAP Joule. AI customers wanting to integrate across their in-house systems and with their third-party and vendor systems will need reliable output formats from their AI tooling. Having outputs that are easier to analyze will also have benefits for governance. One immediate example of this is that OpenAI's new response format includes an explicit refusal flag indicating whether a safety feature had prevented a response. I suspect this is also good timing in the market for the feature. Generative AI has of course taken the world by storm in the last year or two. And at the same time as it's receiving a lot of investment, we're starting to see some signs that we're heading past what Gartner would call the peak of inflated expectations. There's been a number of articles recently, like this one from Goldman Sachs, questioning return companies are seeing on their investments in AI. Now, vendors are going to continue to invest heavily. Google, for instance, has to defend its position in search. But enterprise customers will be feeling an increasing pressure to show value. Structured outputs themselves don't demonstrate value, but I would expect that easier integrations that reduce the cost of implementing solutions, reducing the time it takes to build solutions on top of the LLM tech, it is going to prove popular. Okay, let's assume we are agreed that these structured outputs have potential. So how do we use them, and is it worth it? What I've got here is a nice little project. It provides a comparable level of complexity to a pilot project or an advanced proof of concept. In my mind, what we want to test is that it's easy to combine multiple systems together. Real-world solutions will probably need to combine some kind of UI or workflow, some kind of back-end system, and so on. We want to know that we can dynamically create the schema. That means we can encapsulate the complexity, but keep the flexibility of using the LLMs. We want to be confident that we can validate the schema. And I want to show that I can store the output and use it independently of OpenAI. And finally, all of those engineering concerns aside, for any project, we want to form a view of whether the overall outcome has any value. The raw ingredients I'm using here are Retool as the backend system for making the API calls and acting as the orchestrator, a PostgreSQL backend, in this case provided by Supabase, and of course OpenAI ChatGPT with structured outputs. A front end is also being built out in Retool, and for my little experiment I just ran everything manually rather than building a workflow. And in terms of data, we're using a combination of REST APIs that include a JSON body and some SQL queries. Inside the database, I'm actually using the JSONB data type. That helps me combine a strict schema with some semi-structured data for a more dynamic design. As mind-bogglingly useful as I believe the structured outputs to be, the schema definition itself is really quite simple. So here's the API call. It's just a standard API call to OpenAI's chat completions endpoint. You can see I'm passing in a model parameter and a messages array containing our question, which hasn't changed from existing usage, so for this video, I won't go through them. The response format is what's new and what defines the expected result. Let's walk through the construction of that object. It's a JSON schema object, a standard that's existed for a while now, independent of OpenAI. Although I should note, we're only able to use a subset of the specification here. There's some required fields that don't really have any impact, the name of the schema, and strict must always be set to true. Now we're into the schema itself, and it must always be of type object with additional properties set to false. The real substance is what's happening when you pass data into the properties key here. Basic definition is like this: the name of the key or field that you want and its type. Here's another key, in this case as a number data type. And you can provide any level of nesting, although my instinct is to try to keep things no more complicated than simple key values and maybe a flat array like I have here of strings. Nested structures have a habit of becoming harder to reason about, and I, to be honest, don't really trust LLMs to generate complex structured correctly. That said, maybe that will change going forwards. And finally, all the keys must be listed as required. This might change in the future, and it might only be in the response format just now to conform to the JSON spec. Just list all the keys that you have. Okay, so there's the structure, pretty simple. So let's look at the flow that's been built around that. The user is selecting a node in the knowledge graph. Based on that selection, we build our API call. We can select a model. We choose which fields we want to include in the response. And note that these different fields have different data types, numbers, strings, and arrays. That builds the query, which is a combination of the outgoing message and the expected response format that will come back. I also have some additional logic here to check if there's a cached response already with all the selected fields. That's something you might build into an API, but very simple to build into the front-end app as well. And if any of the fields are missing, we do run the GPT call. We're showing the results on the right. And then, for instance, if I add an extra field to the API call, then we can keep the existing data and only use the additional data from the API response. So that's handling the fact that the LLM will recreate potentially slightly different responses to the other fields. In the background, I can also look directly at the database and see that this has been stored as a JSONB column. End to end, the technical core of this little project and video was just a few hours work, including skimming through the announcement blog and the recipe books. I was able to get fast, good enough results with minimal effort, so my overall conclusion to this little experiment is pretty positive. I've tried the JSON mode previously, and really it just wasn't good enough in my view for integration and automation work. There's kind of just minor issues, such as the format that came back might have been a JSON string and might have additional quotes, so that you didn't always have the same format of response coming back, which was easy enough to resolve. But also the schema couldn't be relied on. You wouldn't necessarily get the exact fields you expected across multiple calls. And that just made it overall just not the right solution for what I wanted to do, which was to be able to populate some data at a reasonable degree of scale. I also think this project did quite well against the checklist. It was easy to integrate multiple systems. It was easy to build the response format on the fly, and it was quite forgiving of errors even. In my query, I never specified which output field should be populated by which part of the message, but the LLM successfully inferred that from the content. Schema validation was pretty easy. I did try a third-party library at first, which was kind of fine, but actually the easiest thing was just the error messages coming back from ChatGPT, which was kind of cool. It's nice to have good quality error messages. I found that particularly useful because it was alerting which parts of the JSON schema were not supported. I tried to format some fields and that didn't work. Also, since LLM calls will always be relatively slow compared to a cached response from a Redis or from a database, it was nice to demonstrate that we can support caching and partial data. And really the only part that would be left is to show whether the overall project has any value. But that's on me to develop the automation and the consumer-facing UI on top of quite a bare bones admin interface here. So as always, I hope this was a useful video for you. The knowledge graph is a work in progress. If I end up using structured outputs, if I get a really quite useful product out of it, I may do a follow-up video. But in the meantime, thanks for watching. My name is John Walls, and I've worked as a technologist for over 20 years, helping tech companies bring their products to market. I also make videos about it, especially the roles, the tools, and the techniques available to the scientists, technologists, and engineers involved. Let me know your thoughts in the comments.